Okay, so this will be the last session for today. Okay, so here as I give you the notes, you see there's a section where you can jot down the Faraday's law and Lenz's law. Okay, and the application for this is the generator. Okay, is the generator. So different between generator and motor is motor have a battery, generator doesn't have a battery. Okay, generator doesn't have a battery. They put the galvanometer, or sometimes they just put a bulb. So you just need to remember the difference, which is DC motor and DC generator both use a commutator. So commutator make sure that the rotation is in the one direction. Okay. So generator will be in a split ring. Okay, split ring. So that's a main difference. Okay, and a graph is the output for direct current and also alternating current. So there is the difference between direct current and alternating current. Okay, so at the bottom here is induction, how to increase induction. This one based on Faraday's law. So to increase induction based on Faraday's law, you need to increase the speed or rate of cutting magnetic field or magnetic flux. You need to use a stronger magnet, or you can increase the number of turns. Okay. So we go to the question. Okay. So first question is, which rule can be used to determine the direction of induced current? To determine the direction of induced current. So because this is an induction, so induction meaning you need to use Fleming right hand rule. So this is very basic. Fleming right hand rule. Fleming left is for force on current carrying conductor. Right hand grip is for you to know direction of electromagnet, magnetic field. Okay. Left hand grip, no. We never learn left hand grip rule. Okay, then we go here. Okay. So this kind of question came out in trial. So you need to know where's the current flow based on Fleming right hand rule. So if you see here, the question state that what happened to the deflection of galvanometer pointer if copper rod is moved upward? Okay, copper rod is moved upward. All right, so this for Fleming right. Okay, this is north, this is south. So this one we doesn't know either it dot or X, but we know this one up. Okay, using Fleming right hand rule, basically it's same like Fleming left, force north to south and current flow. Okay, but this time for right, you want to find the middle finger, the direction of middle finger. So based on my drawing, it will be like this. North to south, force is to the top. So the current flow towards me, meaning the current flow out. So out will be dot. So out, which is here, out. Here, here, here. So what happened to galvanometer? Galvanometer will point it there. Okay, this is a trial question. So where is the direction of galvanometer pointer? So galvanometer pointer will deflect it to the right. Okay. Okay, this one. Diagram show a magnet bar moving towards a solenoid, which action will decrease the deflection, meaning when decrease the deflection, meaning the induced current is low. Okay, induced current is low. Why the induced current low? So you see which factor will make the current low. So to increase the induced current, okay, number one is increase speed. Number two, increase number of turn. And number three, use stronger magnet. Okay, but the question asks you to decrease the deflection. Maknanya dia nak yang lagi rendah. So what will be the answer? Okay, so the answer is C. Speed of magnet is decreased. Okay, good everyone. Najwa, Aina, Akasha, Joanne, Joanna, Jasmine. Okay, good. Good try. And correct answer. So the next one. Okay. So this is what I've told you before. I told you in the previous session. Okay, so the deflection and the pull is depending on the Lenz's law and okay, and where is the motion of a bar magnet. Okay, diagram show a bar magnet move towards the solenoid, bukan move away. So the question asks you it move towards the solenoid. The pointer of galvanometer deflected to the left. Which of following pair of pole is correct? So this one also from your previous trial exam. Okay. So now you know the current flow. So what is your, okay, what did you need to do? What do you need to do is to find the pole on the solenoid first. Okay. Find the pole on the solenoid. Okay. If you find the pole in the solenoid, you need to use a right hand grip. First, for this question, so for this question, first use your right hand grip rule. So based on right hand grip rule, your thumb, the current flow from the back to the front, which is towards me, okay, towards me. So the thumb showing to the right. So right is north. So P is north. Okay. So P is north and this one move towards. So move towards, you want to repel. This is also north. So Q is south and Y is south. Then, okay, then you see north and north, so you see the answer. P and X are north, so P and X are north. So the answer is A. Okay, this is from your previous trial. I don't remember which year, but this is from your previous trial. Okay, so the very basic is what I've teach you previously, which is first you need to know to determine the pole. First, you need to see the direction of magnet move. Either it's towards or away. If move towards, meaning the solenoid want to repel. In other words, it will be the same pole if move towards. Okay, like this one. If you know one is north, the other one will also be north because move towards. So the answer for this question is A. Okay, there's other question you can try. Basically in trial will be much more difficult. In SPM, most of the time for induction in SPM, if you have a past year books, the question will be like this, which is what action will cause, what is the factor. Okay, so that's the way in paper 1. Okay, before I go to the paper 2, I would like to go to the last topic for this chapter, which is a transformer. Okay, so basically you have learned this in PT3, so I don't think that will be much new things for you. It will be the same thing actually. So transformer is a device that can increase and decrease alternating current. So what you need to understand is it's only work with alternating current. Transformer cannot work with direct current, meaning transformer you cannot connect it to battery. Transformer will not work with battery. So it only work with alternating current. Okay, to differentiate between step up and step down is really easy. If you see the number of turn being increased, that means the volt will increase. Okay, the volt also increase. If the number of turn become less or smaller, that means the volt also will be smaller. Okay, so I want to teach you to answer transformer without using this formula, meaning you doesn't need to use the formula at all to answer a transformer. Okay, so we start with this one. Okay, first I want to ask you first, what is the type of transformer? Either it's step up or step down. Okay, my answer in the chat is step up or step down. Okay, down, why you know it's down? First you see the number of turn become decreased, and you see the volt from 240 to 12. Okay, so how many times that the volt reduce? You see, from 240 volt then decrease to 12 volt. How many times the decrease? So 240 divided by 12. Okay, 240 divided by 12. How many times it will reduce? How many times the volt reduce? Good. So it reduced by 20 times. If the volt reduced by 20 times, the number of turn will also reduce 20 times. So basically the formula is a mathematics formula, mathematics for ratio. If the volt reduced 20 times, the number of turn will also reduce 20 times. So the question states that if the primary coil has 1000 turns, calculate the number of turn in secondary coil. So if you have 1000, it reduced by 20 times, what will be the answer? Yeah, so the answer is 50. Okay, you don't even need the formula to answer this. Okay, so same thing, if it's a step up, you see how many times it being stepped up. So the number of turn will increase in the same amount of time. Okay, so another one is this. Okay, I will not show you the answer, even you know the answer already. So based on this one, the difference between the first question and the second question is the first question give you the volt. The second question give you the number of turn. Okay, same thing. This is a step down. So how many times it being stepped down? The volt will decrease with the same number of time. Okay, so it decreased by 4 times, 200 divided by 50, 4 times. So the volt will decrease by a 4 times. 240 divided by 4, you get the volt, right? So if 200 divided by 50, you get 4. So 240 divided by what number, you get 4. So that is meaning of that. That is how the formula being used. So if this is one is 240, there will be a 60. Okay, 60 volt. Okay, good. So the answer is, oh no, D. So the answer is basically D. Step down and 60 volt. That's the answer. Okay. So next one is for what is the usage of this? Basically, transformer used in your power station to up or down the volt. Okay. So basically, it's like this. A power station will produce around like 23,000 volt. But that volt is not enough to supply to every houses, every factory, and every shop lot. So what they need to do is the first transformer always to make it up. Only the first transformer. The other transformer always step down. Only one is up. After the first up, there will be down, 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 and down. Okay. So how many up? Most of the time it's up until 140 kilovolt. 143. So up. Then it moved down because housing area use 240 volt only. Okay. That's how our electrical transmission system being done here in also most of the world. Name the type of transformer. So X will be up and Y will be down. Because there's only one up, the other will be down. Okay, you see this most of the time. This is what we call as national grid network system, which send you a volt, okay, the high voltage. That's why if you saw this, there will be a signboard near to that state danger, high voltage. Okay, danger, high voltage. Okay. So why they use a high voltage or higher energy? Because to transmit the electrical energy from the power station to the housing area, to the shop lot, to the factory, it will take a long distance. So long distance meaning longer wire. You learn in chapter 2 electric. So longer wire have higher resistance. Okay, higher resistance. which higher resistance will reduce the, okay, will reduce, okay, reduce the energy loss. So that's why to reduce the energy dissipate, okay, to reduce the energy dissipate, that's why they send you with a higher voltage cable, okay, higher voltage because they want to reduce the energy loss. Okay. If they use a high resistivity, rintangan tinggi, so current will be not enough for us to use, right? So this one actually is back to the chapter electric. So there's certain thing that you need to go back to electric and understand this before you go to electromagnet. Okay, so the final part of this one is why you can use the formula, this formula, based on one assumption actually. So the assumption is there's no energy loss or no power loss. But in reality, how come you say there's no power loss in reality? So in reality, the energy will be lost, the power will be lost. Due to what? So there's 4 reasons the power is lost. Okay, in transformer. There's 4 reasons the power is lost in the transformer. So the 4 reasons, the first one, it lost due to the resistance of copper wire. Why? Higher resistance, lower current, right? So to improve the energy loss due to the resistance, we need to use a thicker copper wire. Because thicker, diameter dia besar, tebal. So thicker copper wire will have lower resistance. Okay, so the first one basically based on your electric. Okay, the second one is eddy current. So for eddy current is because of this. Okay, so transformer, okay, good question, Aina. I just want to tell you here. That's why. Okay, so eddy current is like this. So basically, why transformer using an induction? Okay, why we say that a transformer using an induction? If we go to the induction, okay, remember back, induction only happen when there is a cutting of magnetic field, which is wire need to move or magnet need to move. And transformer doesn't move. How transformer can produce a current based on induction? Because wire doesn't move, the soft iron core does not move. So how? Okay, the real reason is based on the alternating current. So this side, basically, this side is electromagnet. So example, when current move up, okay, current move up, if you use your right hand grip from the front to the back, from the front to the back, so basically you see your thumb up. So when current move up, so this is north and this is south. Okay. When you use alternating, meaning current can flow in both directions. That's alternating current. So current can flow from the bottom to the top. So now current flow here. So it's changing. One time current flow from the top to the bottom, then from the bottom to the top, and the top to the bottom. So what happened for alternating current? It changed the pull of this solenoid, of this core. So basically, even though the transformer doesn't move, okay, the transformer doesn't move, so this side is changing magnetic field. This side is changing magnetic field. Sometimes it's not, and this is south. And sometimes the upper part is south and the lower part is north. So the changing of magnetic field produce an induction. So this side is basically an induction. Okay. So the question is, what is an AD current? What is an AD current? So AD current is when a current flow through the wire onto the soft iron core. So now there's a current will flow on the core. Okay, there's a current flow on the core that we call as an AD current. So that AD current, okay, that AD current will lose. So when the AD current will lose, meaning the transferring of magnetic field is not good enough. Okay, so this is for your understanding. It will not come out in the exam. Okay, will not come out in the exam. You need to know when there's an AD current. Okay, when there's AD current, energy is lost. So to make sure the current does not lose, what you need to do is soft iron insulated from each other. Meaning this core, soft iron core, you insulate it. Okay, you insulate. Macam lapikkan dia, macam tu. Macam balutkan dia. Okay, bahasa mudah I give you in the simple word is insulate. So the current will stay in the core and does not come out. So that is AD current. Okay. The third one is magnetization of core. As I told you earlier, when there's a current, alternating current flow, the core will be magnet. So when the core will be magnet, there's also energy loss due to that. Okay, because sometimes magnet and demagnetize, magnetize and demagnetize. Okay, so to improve is by using a soft iron core. The fourth one and the last one is magnetic flux leakage. Okay, magnetic flux is like this. Okay, ni. Magnetic flux, like I've told you earlier, this is north, this is south. So magnetic field will flow from north to south as what we have learned in the first subtopic, electromagnet. Okay. So the magnetic flux, if the primary coil and secondary coil is further, jauh macam ni, macam gambar ni, jauh, the flux will leakage. So in order to make sure the flux or the magnetic field does not leak, you put the primary coil and secondary coil next to each other or wounded closer to each other. So the primary and secondary basically rapat-rapat like this. Okay, rapat-rapat. Okay, so if the usual will be like this. Ini primary and this one secondary rapat. That's the usual practice of transformer. Okay, so we go to the paper 2, the one that I looking for before we enter this class. Where's the question? Okay, there's a picture of the spring and the magnet. Okay, this one. Okay, the spring and the magnet. Okay, I give you already in the question, right? Okay. So this one, based on what you saw on the diagram. Okay, based on what you saw on the diagram, spot the difference. Macam main teka-teka dah. Okay, spot the difference between the diagram number 1 and diagram number 2. What is the difference that you see? Good. Okay, Aina state the number of turn. Yeah, that's a one difference. Second difference. The reading of the galvanometer, yes, okay. Reading of galvanometer different. Okay. Did the direction different? The direction of galvanometer deflection? Okay, so the direction doesn't change. Meaning this question want to ask you not about length, because Lenz's law state about direction. Okay, length is about direction, but this question is not about direction. So this question is about the deflection, which is about the magnitude. So which law? So this is asking you about Faraday's law. So that's the main point you need to remember on this subtopic. If the direction is the same but different in magnitude, so the question asks you about Faraday's. If they give you a different direction, the question one is ask you about length. Okay, so that's two things you need to remember. Okay, so first, what is the meaning of electromagnetic induction? So electromagnetic induction is production of induced current from cutting off magnetic flux or magnetic field. Okay, production of induced current okay. My pen have a problem actually. I don't know why. Okay. So then if you see the question, based on the diagram, compare the number of turn. Okay, compare the number of turn. So if you compare the number of turn, number 1 is less than number 2. Compare the deflection of galvanometer, number 1 is, okay, let's see, oh, sorry, number 1 is more than number 2. Number of turn 1 is higher than 2. Okay, sorry. And the deflection of galvanometer, number 1 is bigger than 2. Okay, for comparing, please use the diagram. So see the diagram, look at it carefully. You saw the difference. You saw the difference. Number 3, relate the number of turn and deflection of galvanometer. So the higher the number of turn, okay, the higher or bigger the deflection. Okay. Relate the induced current and the rate of cutting magnetic flux. Okay. Higher rate of cutting magnetic flux will produce higher induced current. Okay, name the physics law. Okay, Faraday's law. Okay, Faraday's law. Okay. Okay, right. So we move to the last one for today is this one. Okay, based on the diagram above, this one also from your trial, state the magnetic pole formed at the end of the solenoid. Okay, what is the pole at the end of the solenoid? Okay, remember the step, the first one, see the direction of magnet movement. Okay, so because if it towards the pole, will be the same. So the answer is good. The answer is not. Thank you for Aina, Akasha. Okay. Aina, Akasha. Okay, no. I have a problem with my pen. I don't know why. Okay, North. Okay, no worry. We go to the question. Number 2, mark the direction of induced current in the solenoid in the diagram. So mark the direction of induced current, okay, on the solenoid basically, okay, on the solenoid. So what is the direction of induced current? Okay, so the arrow will be to the left or the arrow will be to the right? Okay, so this is north and the direction will be like this. Okay, so this is north, so this is south. Use your right hand grip. So we'll be moving here, and galvanometer if showing here, right? But the question doesn't ask you to draw the deflection in galvanometer. It only asks you to draw direction of induced current. So last one, name the physics law used to determine the magnetic pole at X. What law? So Lenz's law. Okay. Good. Thank you, everybody. Okay. So we have around 1 minute. I'm going to stop the share. Oops. What? Okay. All right. So thank you for your time. Okay. Thank you for joining the class. Hopefully this class helped you a lot. I hope. Okay. I really hope it helped you a lot in understanding the topic of electromagnet. Basically, we cover all the topic, the basic and the fundamental understanding. Please do more exercise. We'll see more type of question and do asking. Okay, please ask in the group if you have any other question that you really want to ask, and we will try help you during this school holiday, because you only have 3 weeks before you go to school and start your trial in August. Okay, so thank you so much for your time. We'll see again tomorrow to discuss on electronic. Alright? So happy fasting, selamat berpuasa, selamat berbuka. Okay, jumpa esok. Don't forget to study the topic first and the note that I give you before going to the class tomorrow. Okay, bye-bye. Thank you all. Bye.